Hello everyone and welcome back. In this video we're going to get a very brief introduction to credential storage. Now I want to start this with a disclaimer. This is a very rough overview of cryptography as it is related to passwords. Many of the concepts that we discuss are going to be extremely simplified to make them easier to understand. This course is not a cryptography course, it's not a security course or anything like that. I'm going to give you the bare minimum that you need to understand what these things are. And then if you are interested in this, go forth and research some more. Just keep in mind, these are very simplified examples of extremely complex topics. With that being said, we have to talk about a few terms. We have encryption. I'm sure you've heard the term. Encryption is basically just using an encryption function to turn something into another value. So for example, in this little picture here, it has the plain text that plus the key. The key is important in encryption. You take the plain text plus the key, run it through the algorithm, and you get a ciphertext. Decryption is doing the same thing in reverse. Whenever you take the ciphertext plus the key, run it through the algorithm, and you get the plain text. So encryption algorithms go both ways. They can either take the plain text and make it ciphered, or they can take the cipher and make it plain. Hashing is what we are interested in when it comes to passwords. Hashing is a one-way function. Hashing means that you take the plain text, you hash it, and you get the hash text. But you cannot go in the reverse order. You can't take this and do anything to it to get the plain text back. That is super important when it comes to passwords, because we want to make our passwords as difficult to break, as difficult to hack as possible. And if you use encryption, then as soon as somebody figures out that key, they can apply that key to every other password in your database. However, with hashing, that is not possible because there is no key. There is no way to go from the hash text backwards to the plain text. The only realistic way to do hashing is with brute force. Keep in mind this is a simplified explanation. And then you have salt. Salt is just a unique randomly generated string that's added to each password as part of the hashing process. We'll talk more about salt in a bit and why it matters. So let's talk about encryption versus hashing for just a second. I want to make sure you understand, if you get nothing else out of this video, this is the most important part. Encryption goes both ways. It uses a key to encrypt, and that key can be used to decrypt it. If you encrypt something and you have the key, you can always turn it back into the original. This is what is used oftentimes for data storage and things like that, because you're going to back it up and you're going to encrypt it with that key, but you can always get your data back as long as you have the encryption key. Hashing is not used for data storage. Hashing is a one-way only. It is impossible to decrypt. You must use brute force to get around a hashing algorithm. So here is a very simple, very crappy hashing example, but it'll illustrate the point that we want to get to. So let's say I have this plain text document of just a few numbers. Let's say these are the numbers in my credit card or something like that, and I want to hash them. To hash them, you pass them through a hash algorithm and you get the output. Now this particular hash algorithm is very crappy, very simple. It simply adds the numbers together. 5 plus 3 plus 9 plus 1 plus 0 plus 6 equals 24. You can see how that works this way. However, you can also see that you cannot go backwards. If all you have is this 24, it does not matter what you do. You're never going to get these numbers back without just straight up guessing them. This is how a hashing algorithm works. It's a one-way function. It cannot go backwards. So let's go ahead and get some real-world experience with our hashing. So let's say that we have a password, and we're going to put our password in. Our password is going to be Melon, because you can speak friend and enter. Let's say that's our password. Now we don't want to store this in our database. Let's say we're making our application, we have users sign up. We don't want to put our passwords in the databases. This should be obvious why, but in case you're not sure and you haven't been keeping up on any of the information news, it's easy to get your database hacked. Database hacks happen all the time. So what ends up happening is that if you have usernames and passwords stored in plain text in your database, you've now exposed all of your users' usernames and passwords to whoever hacked them. You will get sued, you will get shut down. It's very bad, don't do that. So instead, we're going to store a hash of that. So let's echo in melon, SHA-SUM. We're going to use SHA-1, or SHA-1, however you want to pronounce it. It stands for Secure Hashing Algorithm 1. It's honestly not secure anymore because they've come up with ways around it, but it'll serve our purposes. So what this will do is this will hash this word that we supplied. There it is. It is hashed. That is the output, and if we run that again, we'll get the exact same number back. It does not change no matter how many times we do it, no matter when we do it, it will always be the exact same. That's what matters. This number right here is what we're going to store in our database. What's going to happen is that whenever the user comes to sign in, they're going to put in their username and password. We'll query the database for their username, get the stored hash, and then whatever they put in, let's say they put in baseball, echo-in baseball, pipe sum, we'll compare that hash with this hash. If they match, then the user will get logged in. If they don't match, then the user will not be logged in. We are never actively comparing their correct password with the input password because we don't have their password. We never see their password, we never get it, we never store it. That is good information security. You should never, ever, ever, under any circumstances, store plain text passwords. Ever. So now we're going to talk about the salt. If you remember, I said that it's just a randomly generated string that's added to the beginning of the password. This is where salt comes in, because right now, let's say we have two users. We have user Gandalf and user Aragorn, and they both have the same password melon. Well, that means that in the database, we now have two of the exact same strings, which isn't that big of a deal at first, unless we get hacked and someone brute forces one of these. Now, they've not only brute forced this one, they've also brute forced that one. Because the hashes are the same. If you don't salt your passwords, whenever they crack one, they've cracked all of them that are the same. And if you have millions of users, you're going to have a lot of passwords that end up being the same, and that's a problem. What a salt does is it simply adds a random string, which is different for each user, to the front or the end or somewhere to this password. So let's say that our first salt is ABC123. That's our first salt. And our second salt is going to be, I don't know, 69420, because apparently I am a 2-year-old. So we've got these two different salts. Those are randomly generated for each user. So let's get melon, echo-in, let's do ABC123 melon. And oftentimes you'll see a delimiter, melon. Sum is right there. And let's say that we have a user with the exact same password, but because we're salting, let's put that through, you'll see that these two are different. They're completely different because we are changing the things in the front. Now what you end up doing is you end up storing the password and you store the salt in your database. And then whenever you are hashing it, you just add them together. This means that each user is going to have a unique hash, even if they have the same password. And all of this, by the way, storing both of the hash and the salt doesn't matter. Because in the database, let's say our database gets hacked and they get salts and hashes, all of the salts are unique, so it doesn't matter. And all they can see is this hash and the salt. They never know what's here, so they can't use that salt to help them crack it at all. This doesn't matter that we're storing it in the database. When we end up storing our users in the database, it's going to look something like this. You're going to have your underscore ID like you always do for everything. You're going to have an email or any other information that you want to get from the user. You might have a phone number, you might have a Twitter username, whatever the heck you want to get from them. They're going to have a username of some sort, and then they're going to have salt and hash. Salt is going to be the randomly generated number that was generated whenever they first signed up, whenever the user first signed up. Hash is going to be the result of hashing their password, adding that salt on there as well. So even if somebody comes in and steals our whole database, all they have is hash and salt. And the only way to get this is to brute force. And the amount of time that it takes to brute force this is dependent upon mainly the length of the password. So let's say that you have a password length requirement of 12, then realistically, nobody's ever going to be able to break that within reason. It'll take years to get that done. You can look up the math behind it if you want, but it's insanely long because it grows exponentially. So this has turned into a relatively long video on a very, very, very complex topic that I've only barely brushed the surface on. A lot of these ideas, as I mentioned, were very simplified. But they're simplified enough that hopefully you can understand them, and we don't need to know the deeper, more intricate workings of cryptography in order to use them. If you are interested in it, go look it up. There's a lot of cool stuff out there, especially if you're a math nerd, but you don't have to because we understand enough that we can use it. In this video, we talked about several things related to cryptography and user credential storage. If you only get one thing out of this video, it's that you should always hash your passwords before you store them. If you ever store plain text passwords, I will find you and I will disown you. Always hash your passwords before you store them, preferably with salt. However, Passport's going to do this for us, so we don't have to deal with creating our own hashing function. Passport is going to do this for us. As always, if you have any questions, please let me know. I'll be happy to help. Thanks.